Modern medicine faces a serious problem. Thanks in part to overuse and misuse of antibiotics, many bacteria are gaining resistance to our most common cures. Researchers are probing possible alternatives to antibiotics, including phages.
So bacteriophages, or we like to call them phages for short, are naturally occurring viruses that infect and kill bacteria. The basic structure consists of a head, a sheath, and tail fibers. The tail fibers are what mediate attachment to the bacterial cell. The DNA stored in the head will then travel down the sheath and be injected inside the cell. Once inside the cell, the phage will hijack the cellular machinery to make many copies of itself. Lastly, the newly assembled phages burst forth from the bacterium, which resets their phage life cycle and kills the bacterium in the process.
Someday, healthcare providers may be able to treat MRSA and other stubborn bacterial infections using a mixture of phages, or a phage cocktail.
The process would be first to identify what the pathogen is that's causing the infection. So the bacterium is isolated and is characterized. And then there's a need to select phage in a process known as screening of phage that are either present in a repository or in a so-called phage library that allows for many of the phages to be evaluated for effectiveness against that isolated bacterium.
Phages were first discovered over 100 years ago by a French-Canadian named Félix d'Herelle. They initially gained popularity in Eastern Europe. However, Western countries largely abandoned phages in favor of antibiotics, which were better understood and easier to produce in large quantities. Now, with bacteria like these gaining resistance to antibiotics, phage research is gaining momentum in the United States once again. NIAID recently partnered with other government agencies to host a phage workshop, where researchers from NIH, FDA, the commercial sector, and academia gathered to discuss recent progress. NIAID also conducts and supports research on phages.
The research that I'm working on now is aimed at answering the question of what makes a good phage for phage therapy. There's a diversity of phages out there, and how do we choose or engineer the best phages for use for therapeutic purposes?
Through research on phages and other efforts, NIAID is committed to outpacing antimicrobial resistance.